A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Now, dear students, today we are going to solve the real test 5.1. There are only 30 to 34 questions in a previous paper. So, first question that appears, you can see the sum of all the forces or all the torque on a body is 0. Then the body will be in a, look at this one, sum of all the forces and all the torque on a body is 0. Then the body will be in the state of the total condition. This equilibrium condition is known as total condition. When only forces, sum of all the forces is 0, then first condition. When all the torque, external torque is 0, then that was the second. But over here in this problem, the sum of all the forces and all the torque on a body is 0, then the body will be in the equilibrium. So this condition is known as total condition. So in question number 1, option C is a correct answer. So question number 2, when we talk about the question number 2, the direction of force exerted on a surface of a liquid at a rest is on a surface. Whenever the force is applied on a surface, that one is a normal to the surface. So option C is a correct answer for question 2. Question number 3, beta. A body is in equilibrium under the certain action of the 4 equal forces. The vector diagram will be 4 equal. That means that the diagram will be square. So after question 3, again the C option is a correct answer. And question number 4, the Jupiter in equilibrium as obviously by the Newton's first law. So question number 4, option A is a correct answer. Question number 5, weight of a body acts at, when you talk about the forces that act at the center of the mass, but when we talk about the weight that acts at center of gravity. So option B for question number 5, option B is a correct answer. So then after question 5, question 6, in question 6, the cross product of momentum and the force is known as, you know already that, momentum and force, the cross product, that's always produce a torque. That means for question 6, option B is a correct answer. And in question 7, the magnitude of the torque is given by, when we talk about the torque is a vector, should have the magnitude as well as the direction. If you go through this torque, so torque is equal to what? RF sine theta and the unit vector which shows the direction. When we talk about the magnitude only, that means RF sine theta. So this one is the magnitude. So in question number 7, option A is a correct answer. So then in question number 8, so the torque is equal to RF when the angle between them is, this occurs in 2003. So exactly, that means the maximum torque, and torque will be maximum, you know that. Torque, magnitude of the torque, if let's suppose the magnitude of torque is equal to RF, that means sine theta is 90 degree. So maximum torque is always as 90. So question number 8, option A is a correct answer, 90 degree. Then after that, after question 9, when we are going to solve question number 9 now, after question 8, question number 9, 2 equal and anti-parallel and non-collinear forces act on a body, forms a couple. Option C, you know that. Let's suppose this one is the object. 2 equal, they have the same magnitude, F1 having the magnitude, let's suppose F, and over here F2, that's also having the magnitude same F. They are anti-parallel, exactly, the direction is opposite. non-collinear. That line is, that force is passing through that one. They are non-collinear. Act on a body, they forms the couple, they produce the couple. So that means question number 9, option C is a correct answer. In question 10, when we talk about the question 10, the torque acting on a body determines that, that force produces the linear acceleration when the torque produces the angular acceleration. So option C is a correct answer for question 10. Then question 11, which one is not a type of a dynamic equilibrium? Rotational equilibrium, exactly, there is a dynamic, means there is a motion. Translational equilibrium, yeah, when in part C, static equilibrium, this is not the dynamic equilibrium. So that means option C is a correct answer for question 11 as well. So in a question 12, the time that referred to the rotation of the earth about its axis is known as, जो अर्थ रोटेट करती है टाइम, उसको क्या कहते हैं? यूनिवर्सल टाइम कहते हैं. दैट मीन्स ऑप्शन सी इज अ करेक्ट आंसर. क्वेश्चन नंबर 13 देन, द डायमेंशन ऑफ द मोमेंट ऑफ इनर्शिया. You know that moment of inertia represented by I is equal to mr square. So when you talk about the mass, the dimension of the mass is m, dimension of the radial distance is l square, so ml square. And when we talk about the time is not present, so ml square t naught, means option D is a correct answer for question 13. When we talk about the question number 14, the resistance of an object of a change in its rotational motion is called moment of inertia. We have already done. So option D is the correct answer. Question 15, moment of inertia depends upon mass and its distribution with respect to the axis of the rotation. Okay. Volume of the body, no, it doesn't depend on the volume. Kinetic energy, no. Angular momentum, yes. That means option A and D are the correct answer. That means for question 15, option E is the correct answer. You know why? Because they're either A or D. It depends on these both. So after question 15, now we are going to solve question number 16, beta. Question number 16 here. The moment of inertia a 1000 kilogram sphere, mass is given, m is given, 1000 kilogram, this mass is given. Sphere of diameter is given 1 meter. We need the radial distance, means r is equal to what? D upon 2, that means 1 divided by 2, that's equal to 0.5 meter. This one is the radial distance. So you have to find what? Moment of inertia, means I is equal to what? You know that. It's very easy. I is equal to what, beta? I is equal to mr square. So here 1000 multiplied by 0.5 square. So that's equal to 1000 multiplied by 0.25. When you take the square, that's equal to 250 what? Kilogram and meter square. This one is the answer. So option C is a correct answer for question 16. Then in question 17, and MCQ number 17, a point which moves as if the total mass of the body or the system of the particle were concentrated there and all the applied forces were acting at that point is known as, that if the gravitational force would be there, that would be the center of the gravity. But here, the center of the mass of a body. So in question number 17, when we talk about the options, option B is the correct answer. All the forces appear to act at a body at a point, and the body produces the translatory motion. That means that point is known as center of mass. In question number 18, beta, the dimension of the angular momentum are, when we talk about the angular momentum, L is equal to mvr. And you also know that the dimension of the mass is m, velocity lt raised to minus 1, and r, that one is L. So that means m L square t inverse 1. So option C is the correct answer for question number 18. So today the task is very simple one, that beta. in chapter number 5, rarely the one problem is being given in since last 20 years. So after the question number 18, when we solve question number 19, which of the following are examples of the spin motion? The daily rotation of the earth about its own axis, yes, this one is a spin motion. Rotation of the flywheel about its axle, right, this one is also the spin motion. The motion of the planets around the sun, no, this one is orbitary motion. That means option 1 and 2 are the correct answer. So for question number 19, option D is a correct answer according to the given sheet. So question number 20, when we talk about the question number 20, the torque will be greater if both the magnitude of the force and the moment arm are smaller, no. Both the magnitude of the force and the moment arm are greater, yes. Only magnitude, no. Only moment, no. That means option B is a correct answer for question 20. And in 21, question number 21, examples of the spin motions are the daily rotation. This one is being repeated but in a different way. The daily rotation of the earth about its axis, yes, this one is a spin motion. Jumping of a parachute from an helicopter, no. Flow of the viscous liquid, no. Rotation of the flywheel about its axis, yes. Means option A and D are correct answers. That means E option is the correct, that shows that both A and D. In question 22, beta, identify the examples of the static equilibrium. A book is lying on a horizontal table. Yeah, exactly. This one is the example of static equilibrium. A building, yes. Building is not moving. That means static equilibrium. A bridge, yes. That is also the example of static equilibrium. That means option 1, 2 and 3. Option 1, 2 and 3. That means E is the correct answer again. So 23, question 23. Over here, the formula is given. And L is equal to R cross P. R means position vector, P means linear momentum. Cross product of the position vector and linear momentum is always known as angular momentum. So in I in this equation will be angular momentum. So option C is the correct answer for question 23. Question number 24. The examples of the dynamic equilibrium is dynamic equilibrium. The jumping of the parachute from the helicopter, yes. A cup lying on a horizontal, no. A building standing in a city, no. That means only option A is the correct. So on question 24, option A is the correct answer, only first part. So after question 24, question number 25, better now. The magnitude of the torque is equal to magnitude of the force and momentum. This means that the smaller the force, the larger will be the torque. No. The greater the force, the larger will be torque. Yes, that's a correct. B is a correct answer. Then the larger the moment arm, the greater will be the torque. Yes, that's also correct. So option D is not correct because both by increasing the force or by increasing the moment arm, the torque will increase. So that means option E is a correct answer for question 25. Then question 26. The center of the mass of a system of the particle coincides always with the center of the gravity. No. Never coincide. It's not correct. Coincides always with the center of the gravity only in a uniform gravitational. Yes, that one is the correct answer. Option C is the correct answer. So in question 27, the torque depends on, that formula for the torque. Torque is equal to moment arm and force. That means it depends on the force and the momentum. So option B is a correct answer for question 27. And when we talk about the question 28, jumping of the paratroops from the helicopter is an example of dash equilibrium, dynamic equilibrium. So option C is a correct answer. In question 29, a torque which produces the counterclockwise rotation. Counterclockwise means anti-clockwise, is considered to be positive, and producing a clockwise rotation, that's equal to negative. That means option C is a correct answer. You know that When we move anti-clockwise like this, when we move anti-clockwise direction, angle is going to increase. Angle is going to increase. That's why anti-clockwise rotation produce the increase in the quantities. Which quantities? Pseudo vectors. So after 29, in a 30th question number, every point of the spinning about object moves along an arc of the circle in a small interval of the time, and the center of all the circle lie along the straight line. This straight line is known as axis of the rotation. So in a question 30, option C is a correct answer. In question 31, when you go through the 31, identify the correct answer. The turning effect of a force about an axis is known as torque. Okay, that's right. The unit of the torque is Newton meter. It's okay, it's also right. The relation between the torque and the moment of inertia is torque is equal to I over alpha. That's okay. You know that. The torque is what? Rate of change of angular momentum. Delta T. You know that. Torque is equal to L. L is equal to what? I omega over delta T. So that means torque is equal to what? I over here. Rate of change of angular velocity is known as alpha. That's why torque is equal to I alpha. That means option C is also the correct. So the moment of the inertia of the gramophone record about an axis of the rotation. So over here, in a D part, okay, I'm solving this part as well. So when we talk about the part D, in a D part, the moment of the inertia I is given. I is equal to what? I is given 6 into 10 power minus 3 kg meter square. Then angular acceleration alpha is also given. That's given 3 pi radian per second square. And torque is also given. Torque is given how much? 5.65 into 10 power minus 2. Is that statement correct or not? So you know that when we calculate this statement, so you know that the torque is equal to what? I into alpha. So I is given what? 6 into 10 power minus 3 into alpha. Alpha is 3 pi. So 6 into 10 minus 3 into 3 into, when we put the value of the pi, that will be 3.14. The answer will come out as, answer will be 56.52 into 10 power minus 3. When we calculate this one, that answer will be, so the answer is 5.652 into 10 power minus 3 over here, 10 power minus 2. That one is the correct answer. So that means this statement is that's why in question 31 option E is the correct answer, because all the given statements are correct. We have verified them as well. So after question 31, 32, a body at the rest or moving with a uniform velocity has zero acceleration from the Newton's first law of motion. The vector sum of all the forces acting on it must be zero. This is the condition. Which condition? First condition, 32. Option A is the correct answer. Question 33. The vector product of the position vector R and F is called, you know that, torque. Option B is a correct answer. 34 and the last one. This one is the last question. Two forces equal in magnitude but opposite in direction and not acting along the same line constitute the couple. The moment of the couple will be independent of its location of the origin. Depending on the location, no. Zero, no. Scalar product, no. That means option B is the correct answer. That's all. So up from 1998 up to 2018, all the questions which we have from the universities that is being done. Thank you very much and may God bless you.